Hello, welcome to everyone in this video. This is our lecture number 2 of the quantum mechanics theoretical part. In the lecture 1, we discuss about the basic of quantum mechanics and de Broglie hypothesis, Planck constant, Planck radiation, Wien's displacement law, etc. will be was discussed in lecture number 1. If you want to watch this lecture, you can go through the description box, link are given there, and there is a separate playlist for the solution of quantum mechanics and the other part of the physics like classical mechanics, mathematical method, and etc will are having the different playlist. You can go through the description box or you can go through the channel. You will be get different playlist for physics related video, some mathematics, and the problem solution of physics. Okay, so in this video I want to discuss about the photoelectric effect. So let's start with was the photoelectric effect. You can see the syllabus of Calcutta University for graduation or the B.Sc honors. This part actually discussed in the first lecture, that is black body radiation, Planck's quantum hypothesis, Planck constant. In this lecture we want to discuss, and the de Broglie wavelength also discussed there. Here we discuss about the photoelectric effect. What do you mean by photoelectric effect? In the starting of the quantum mechanics, we discussed that the quantum mechanics actually start from the Planck's radiation law, where this energy taken as the h nu. This is the starting point of quantum mechanics, which is used in the photoelectric effect, Compton scattering, etc. So let's know about the photoelectric effect. What is the photoelectric effect? If you photoelectric effect. If you consider any metal, this is a metal, this is a metal. Okay. In this metal, fall a light wave. This is a light. Here, this light taken as a photon particle. Photon. That is the quanta of energy. Quanta of energy. Whose energy taken as the h nu. Whose energy taken as the h nu. So, in this metal, the energy fall, which is h nu. After falling this energy, after a sorry, above a minimum energy falling on this metal, their ejection of the electron. This is called photoelectric effect. Photo for light, electric means electron. That's mean here the light energy or the photo energy, light energy, here the light energy converted into the electrical energy. Here the light energy converted into electrical energy, right? Here the light energy converted into electrical energy. So you need to incident the energy, minimum energy, such that the electron can eject from the metal to its surface. This minimum energy is known as the h nu naught, which is known as work function. So this is nothing but the work function. That means this is the minimum energy required, minimum energy required to eject electrons from metal to its surface. This is the known as the work function. Work function is the minimum energy which is required to the electron comes from this metal to its surface, right? This is the work function. So this amount of minimum energy is required to eject the electron or the occurring of the photoelectric effect of that metal. For this will be the different value for different metal. So this is the minimum energy. Above this, the excess energy, it will have a kinetic energy. It is as a kinetic energy. So the total equation will be like that: h nu, which is incident energy, h nu naught, which is required to eject from this metal to its surface, and the ek is the kinetic energy of this electron. So you can say this is incident energy, This is the incident energy, which energy incident on this metal, and this is the work function. This is required to eject the electron from its surface, to eject to its surface, eject electron from metal to its surface. This is known as the work function, right? Work function. And the rest of this energy used as the kinetic energy of electron. Kinetic energy of electron. So I think clear. This is the Einstein's equation of photoelectric effect. The Einstein's equation of photoelectric effect. This is the Einstein's equation of photoelectric effect. Okay, so I think clear about the Einstein's equation of photoelectric effect, which has three parts. First one is the incident energy, which used as a two portion, that is the work function, that means energy required from metal to its surface, and the rest is the kinetic energy of this electron. No problem. Now if you consider the total circuit of this arrangement, if you consider the total circuit of this arrangement like that, there is a metal, this is a metal, and in this metal fall on this light wave with energy h nu, and the electron used the work function, and the rest of this energy electron is a ek. Okay, no problem. Now if you consider there is a plate, this is a taken as the negative here, negative no, positive here, there is a positive here. If you consider this is positive plate, then what happens, this electron comes here and they flow the current. Okay, so if you wants to draw this diagram, that is the voltage versus current, this is the current, and this will be the voltage V, this is the voltage. If you want to draw the diagram for the voltage versus current IV diagram, you can see, if you if there is no voltage, if you consider there is no voltage, what happened, that means at the zero voltage this electron must ejected from there and flow something from some. So at the zero voltage there also a some current, right? So there is a current, although this voltage is zero, right? Now if you increase the voltage, what happened, this electron actually ejected, and some are go through away from that region. All are not collected from this plate, but when this voltage is increases, this attraction will be increased, and this ejected electron also comes towards this plate, and this current will be increases. Okay, after that this will be saturated. Why this saturated? Because the intensity of light is fixed. This intensity measure the how many number of electron available in this region. With increasing voltage you increase this current, because this some electron ejected or throughout from this region. But when this voltage is increases, these are go through this plate. But there is a limitation of available electron. When all electrons come through this plate, after that there is no increment of this current. This current will be saturated. So why saturation? If you say why saturation saturation of current happen, so you can easily say that is the number of available electron is limited, which depends on the intensity of incident photon. Okay, so I think clear. That is the, since the incident of photon is fixed, that means the number of available electron is fixed, that's why the current will be saturated. And why this increment? Why initially current is increased? Why this initially current is increased? Because some electron deflected which are collected by the plate when applied voltage increased. Applied voltage increase. Clear? When the applied voltage increase, then this the deflected electron are collected by this plate, so that's why this increment will be happen, and after that this is saturation. Clear? Now if you increase the intensity of the incident photon, what happen? Suppose this is I1. If you increase the intensity of photon, then the available electron will be increases. Then the electron this at the 0 voltage this will be increases, and this is the nature will be like that. So this is the for I2 which is greater than I1. This is the intensity variation. Intensity of incident photon variation. Clear? If you increase the intensity, what happen? The number of electron available in this region will be increased. That's why the initial current increase. After that, some electron are deflected. So if you increase the available this voltage, this are the increase the current, and after that this is saturation, because there is a limitation of the available electron which depend on the intensity of the incident light. So I think clear why this is increases and why this is saturation. Now comes into the negative bias. If you change this bias direction in the opposite direction, then what happens? Same thing. This is a metal. Okay. There is a intensity h nu in photon incident and electron ejected by this work function, and after that this will be comes with the kinetic energy ek. Now this plate is connected. Now this plate is connected by the negative voltage. By this negative voltage. Then what happened? This is this negative reflect. So the current will be reduced. So the current versus voltage curve will be like that. The voltage and the current. Okay. Current. The forward graph will already discussed. This forward graph will be like that. Sorry. I just want to like that. Okay, the forward graph already discussed is like that, which is depend on the intensity. now what happen if you increase this negative voltage, then this electron are reaching, that is reduces. So this curve will be like that. There was a I1 and this was I2, and which is greater than I1. Now if we increase this negative voltage, then the number of electron which are reaches here will be reduces, and which reduction of the electron reduce the current. Here this measurement of the current, so this current will be reduces. After a certain voltage this will be zero, and this voltage is known as the stopping potential. At this stopping potential, the kinetic energy of the electron must be equal to the potential energy. So at stopping potential, that's why this electron cannot reach at that point, because this stopping potential oppose this electron, so this energy of this kinetic energy equal to the potential energy, these two are equal. So at stopping potential you can say that is kinetic energy equals to potential energy. So the Vs eq will be like that, or from here you can easily find out the velocity half mv square. V small v is the velocity, so v is nothing but 2 e vs by m, mass of the electron. This is the velocity of electron, maximum velocity. This is actually maximum velocity of electron, maximum velocity of electron, which can be calculated by this graph. Now this is the intensity at 1, but in the second case when the intensity increases, this will be increases, and if you reduces the applied voltage in the negative portion, that means because this kinetic energy depends on the energy of the incident, not depend on the intensity. That's why the stopping potential will be same. So the nature will be like that. Okay, so nature will be like that. So this is the actually total intensity variation. Okay, so I think clear why these stopping potential are same. Why the stopping potential same? Why stopping potential same for different intensity of light. Okay, what is why the stopping potential same for the different intensity of light? Because because uh, because the stopping potential depends on depends on the stopping potential depends on the maximum kinetic energy of electron, which is h nu minus h nu naught, that is the incident energy minus work function. Total equation you remember, that is h nu equals to h nu naught plus ek. So ek equals to h nu minus h nu naught. Since the h nu is constant, so ek is constant, that's why the stopping potential will be constant. So if the intensity variation, then the curve will be like that. I think clear about the intensity variation. What happen if you change the frequency? So what happen when we change the frequency of incident electron? This is the metal, the incident nu1 and h nu2, two case. So the electron will be like that. So remember this equation, h nu equals to h nu naught plus ek. ek is nothing but e vs, right? So remember this diagram, this was the connection at the front side, this will be, and the voltage will be negative in the other side. So the curve will be like that. This is voltage, and this was the current. Now the curve was like that for intensity 1, or some intensity or frequency nu1. This is for nu1, so nature will be this vs1 for stopping potential for nu1. Now what happen when you increase the, if nu1 nu2 is greater than nu1, when we increase the frequency, then the EVS1 will be increases because the EVS equal to H nu minus H nu naught. Since nu is increase, Vs also increase, so Vs2 is greater than Vs1. So the curve first will be starting from somewhere here. Somewhere here the curve will be starting Vs2. In the negative side, this will be the increase. After that, it will be increase the initial current also. It will be increase the initial current also. But here the intensity is same, and you know intensity is the count of the available electron in this region. That's why this saturation will be same. Clear? So this is for nu2. Nu2 is greater than nu1. This is the frequency of incident photon variation. So frequency of incident photon variation. So this saturation will be same. Why this saturation same? First one, why stopping potential different? Sorry, why this stopping potential different? Stopping potential different. Why this stopping potential difference? Because because incident energy increasing. Because incident energy increases means kinetic energy increasing. That is maximum kinetic energy of electron will increase. Since the maximum kinetic energy of electron increase, that's why stopping potential increase. Stopping potential increase. Clear? Increase. Okay. But why now forward saturation is same? Because this forward current, because it depends on intensity of incident photon, which is same. Incident photon, which is same here. Clear? That's why the curve for the two different frequency will be like that. I think clear about the frequency variation and the intensity variation curve for this experiment. Okay. So comes again. So we know about the stopping potential. Here is the stopping potential. Know about the frequency, minimum frequency, which is actually known as the threshold frequency. The nu naught actually known as the threshold frequency. Threshold frequency. So you know about the minimum frequency to eject the electron from this. That is known as threshold frequency. Now comes into the another part, that is we already know about the h nu will be used as h nu naught as a work function plus ek. So this is h nu equal to h nu naught plus ek is the e into v naught, vs stopping potential. Okay, so nu naught no. Sorry. So h nu minus e vs equal to h nu naught. So you can write this is nu by nu naught plus vs by h nu naught by e equals to 1. So if you draw the curve about nu versus vs stopping potential, this is the frequency, and this is the stopping potential. Now just look about this. This is the x by a plus y by b equals to 1. Oh, there is a minus also. So this is the intersect equation of the straight line. Intersect equation of straight line. Equation of straight line. Okay. So this curve nature will be like that. At the x-axis cut at nu naught and y-axis that's all. So the nature of the curve will be like that. No problem. Cut at this nu is the nu naught, which is threshold frequency. Cut at the y equals to h nu naught by e. So the slope of this curve, slope of this curve will be like that. That is the h nu naught by e by nu naught. That is the h by e. So from the slope of the curve we can find out the value of h. So h, that is the Planck constant, will be slope into e, electronic charge. That is the Planck constant. So Planck constant can be find out by this curve. Also you can find out this, that is the threshold frequency. So if you take a different nu and if you find out this different stopping potential using this experiment, you can draw this straight line. After getting the straight line, you will be get the threshold frequency of this metal, and you will be get the value of h also. Okay, so I think clear all about the experimental data here also. Now I want to discuss something else, that is just starting about the Einstein's equation, that is h nu equals to h nu naught, which is work function, plus ek, kinetic energy. So you can write down this is h nu equals to h nu naught, and this is half m v square. V is the maximum velocity, there v is the maximum velocity. Okay, v is the maximum velocity. So you can write down that is half mv square is nothing but h nu minus nu naught. So here you can find out this maximum velocity is nothing but 2h nu minus nu naught by m. This is the expression to find out the maximum velocity. And the stopping potential expression v is in terms of stopping potential also here. So just you can use these two formula, which is required. Okay, which is required. Available data are given in these two things. So this is the maximum velocity expression. From these two things you also get find out this relation, that is EVS, stopping potential. So Vs is nothing but 2h by e nu by nu naught. Stopping potential expression. Stopping potential. So I think cleared all about the photoelectric effect. This is the threshold frequency. Threshold frequency, and nu is the incident frequency. Okay. So I think clear all about this thing which want to discuss in the photoelectric effect. If there is any doubt, you must comment in the comment box, right? So this is all about me. This is my contact detail. You can connect with me with this Telegram channel. This is all my online platform. This is my YouTube channel details, fees by Laxmikanta sir. You can go through this channel. You will be get different related video, theoretical and problem solution. Like this session, if you learn something from this session, share this video to your friends, either he or she also get benefit from this video. Subscribe this channel if you're new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get notification of upcoming videos. So take care. We'll meet in the next video as soon as possible. Thank you.